This video goes over the notes from section 19.2, part 2, factoring trinomials when a is not 1. So the first thing I want to point out is that anytime you are factoring, you always need to check for a GCF. So if you take a look at example 1a, we notice that all three of those terms are divisible by 3. So the first thing we're going to do is factor out that 3. So I write down my GCF, and then in parentheses I'm going to put what's left after I divide each term by 3. So 3x squared divided by 3 is x squared, and 36x divided by 3 is 12x, and negative 84 divided by 3 would be negative 28. Notice that all I did there was basically the opposite of distribution, and so I pulled that 3 out, and then if I multiplied it back together, I would end up with what I started with. So the reason that I did that is because now notice the thing in parentheses looks like what we were doing in part 1. So we can actually factor it in the same method we used for part 1. So I'm going to keep my GCF, and I'm going to bring down 2 sets of parentheses. And I have my x and my x, and I'm looking for 2 numbers whose difference are 28, since it's a negative 28. So I have 1 and 28, difference of 27. That doesn't work. 2 and 14, difference of 12, which is what I meant to say a second ago. We're looking for a difference of 12 there, since that's our middle number. So now I just need to figure out which number needs to be negative in order to give me a positive 12. So I'm going to need to have positive 14 and negative 2. And then I can't factor anymore. There's no GCFs in any of our factors, so we are done with that one. Let's take a look at B. So once again, I'm going to look at all 3 terms and look for what they have in common, and this time I notice they have a 2 in common. So I'm going to factor that out. So I'm dividing each term by 2. I end up with x squared minus 8x plus 12. And then once again, I notice there's no number in front of that x squared, so I can factor it like I was doing in part 1. So my x and my x. I'm looking for 2 numbers who multiply to give me positive 12. So the factors need to have a sum of negative 8. So I have 1 and 12, sum of 13. 2 and 6, sum of 8, but since it's negative 8, both will need to be negative. That should have been a 2. This is just refer back to part 1 video if you're struggling with factoring when a is 1, so when there's no number in front of that x squared. Okay, and let's take a look at C. So this time I noticed that my GCF is 4. So I'm going to factor that 4 out, divide each part by 4, and then we're going to factor what's in the parentheses. So I have my x and my x, 44, and I'm looking for 2 numbers who multiply to give me 44 and who add to give me 15. So 1 and 44 doesn't work, 2 and 22 doesn't work, 3 doesn't go into it, 4 and 11 adds to 15, so I do plus 4 and plus 11. So that takes care when there is a GCF, and when you factor that out, you're left with just x squared. You can look at this example here to see what you do when a is not 1 and you don't have a GCF. So I'm going to actually describe this on the next slide. Okay, so taking a look at example 2, we are factoring this, and we're using what's called the M method. So when you look and there's no GCF between all 3 terms and there is a number in front of the x squared term, this is the method we're going to use. So we're going to do first times the last, and we get 12x squared. We're looking for 2 terms that multiply to give us 12x squared and add to give us negative 8. So I'm looking for 2 numbers whose product is 12 and whose sum is negative 8. So we have 1 and 12, that gives us a sum of 13. 2 and 6 gives us a sum of 8. So they're both going to need to be negative in order to give us negative 8. So I'm going to split that middle term, and I'm going to split it into negative 2x and negative 6x. And so notice I just rewrote this negative 8 as negative 2x plus negative 6x, or negative 2x minus 6x. And then I'm going to bring down this first term, and then I'm going to bring down this last term. Okay, so let me just recap what I did there. I found my two numbers, and then I brought them down, and I split that middle term. So I rewrote my original expression into a 4-term thing. And the reason I did that is because there's a special method that we have for factoring things with 4 terms. We're going to split it into 2 terms, and we're going to factor out the GCF on both. So looking at this first set of terms, what goes into both terms? What can I pull out of both? Well, 3 and 2, the GCF of 3 and 2 is just 1, but they have an x in common. So I'm going to pull that x out. And when I do that, 3x squared divided by x is just 3x, because 3x times x equals 3x squared. Negative 2x divided by x is negative 2. Okay, then I'm going to pull this middle sign down, and then I'm going to look for my GCF of the second thing that I underlined. So between negative 6 and 4, the GCF would be 2. They don't have x's in common because that 4 does not have an x. So I'm going to divide that second group by negative 2. Negative 6x divided by negative 2 is 3x, and 4 divided by negative 2 is negative 2. So I'm going to take the thing that's inside. Notice how it's in common. Both of them have that in common. That's going to be one of my factors. And then the stuff that's outside, that x minus 2, that's going to be my other factor. So it looks similar to the answer we got in part 1 of section 19.2. But notice this 3 right here in front. That's because when we multiply this out, 3x times x is going to give us that 3x squared that we started with there. Okay, that was probably a little bit confusing, so let's do another one of those. Try to clear that up. So once again, I notice that my initial term, my first term, has a number 5 in front of it, and so I'm going to use what we call the M method. So I'm going to multiply first times the last, and I get 60x squared. I'm looking for two numbers who multiply to give me 60x squared, and who add to give me 19. So we have 1 and 60. That's not going to work because the sum is 61. 2 and 30 have a sum of 32. 3 and 20 have a sum of 23. 4 and 15 looks like it's what we're looking for. So we split that middle term to 4x plus 15x. Still equals 19x, so we're not changing anything. Bring down our first term. Bring down our last term. And then underline the first two and the last two. We're going to factor by grouping. So my GCF of this first set is once again just going to be x, because 5 and 4, the GCF of those is just 1. I factor those out. I'm basically just pulling an x out. So I have 5x, and then 4x divided by x is just 4. Pull down that middle sign. My GCF between 15x and 12 is 3. 15x divided by 3 is 5x, and 12 divided by 3 is 4. Once again, notice those inside those parentheses are the same. If they weren't, that would tell you that you've done something wrong. That's going to be one of our factors, and then the outside stuff is going to be your other factor. All right, I want you to pause the video and try example C, and then check it and make sure that you did it correctly. Okay, so take a look at what you tried and the work that I've showed here and see if you have the correct answer. And then let's go ahead and go to example 3. So first of all, I had to apologize, but example A here is a giant typo, so hopefully we'll get it fixed before printing this. But let's go ahead and write out a new example, and we'll just change it in your packet if you don't have a different one than what's here. So let's actually make this instead 7x squared minus 20x minus 3. So just like in part 1, we want to make sure that one side of the equation equals 0 before we start factoring. And just like in example 1, we want to see if there's a GCF that comes out of all 3 of the terms. And in this example, there's not. So we are going to go ahead and do the IMP method. So start with doing first times last. And that gives us negative 21x squared. And we're looking for 2 numbers whose product is negative 21 and whose sum is negative 20. And so we're looking at the difference of the factors here. So we have 1 and 20, 1 and 21, sorry, whose difference is 20. And 21 would have to be negative to give us a negative 20. So we're going to split this. Negative 21x plus 1x still gives us negative 20. Pull down that 7x squared, pull down that negative 3. And then we're going to go ahead and factor by grouping. So we pull out a 7x, gives us x minus 3. Pull down our plus sign. Notice that there's nothing in common between these second 2 terms, so we're just going to put a 1, which doesn't change anything about them. And then we have what's inside and what's outside equals 0. So if you recall from part 1, now we take each factor and set it equal to 0 and then solve. So we'd add 3, subtract 1, and then divide by 7. So those are our 2 solutions. Okay, so I want you to take a look at B. And first we are going to get one side equal to 0. So I'm going to move this 1 over. That x squared really works better if it's positive, and it is already. Let's put that 1 on the end. Now I want you to pause the video, do the M method of factoring, and then press play to check your work. Okay, this should be what your work looks like, and your final answer here should look like 6x plus 1 times x plus 1. And then lastly, we just have to set each factor equal to 0 and solve. And you end up with these 2 solutions. Go ahead and let's do the same. Let's do the same thing for this one. We want to start by getting our one side equal to 0. And so our 6x squared is positive. So we're going to move everything to that side. And so we end up with 6x squared plus 5x minus 6. We check for a GCF, and there is not one. So we're going to do the M method. So once again, I want you to pause it and try that, and then you can check your work by pressing play. Okay, if you made any mistakes, go ahead and fix them. And then once again, I want you to pause it, and I want you to go ahead and set those equal to 0 and see if you get the correct solutions, and then press play to check. All right, so here are your final x values that you should have gotten. Go ahead and fix any mistakes that you made in your notes and ask questions if you have any.